My name is David Cadena, and in this video, I am going to run you through the program of the lottery picker exercise. Let's run the program. It is asking me how many Lotto numbers I want to generate. Once I enter, let's say 4, I get 4 rows of random numbers. Now, it is giving me the opportunity to see more numbers by entering the letter Y, and to not by entering the letter N. I'd like to see more, so I'll enter Y. It again prompts me for the number of Lotto numbers to generate, and this time I'll enter 2, and I only get 2 rows of random numbers. If I continue one more time and I enter 7, I get 7 rows. I don't want to see any more numbers, so I'll enter the letter N. Before the action begins, we have 6 libraries that we will use throughout the code. We used the IOStream library, the vector library to use the vector class, the IOMANUP library to align the numbers and the rows to the right when displaying these numbers, the CSTDelib class for the random number generation, the algorithm class for sorting the numbers in the vector in ascending order, and finally, the seedtime class to generate a random seed. Okay, let me walk you through the rest of the code. Not including main, the code contains 3 functions. The getNumbers function, where 5 random generated numbers are added to a vector, the setPowerball function that generates and adds the Powerball random number to the vector, and finally, the showNumbers function that displays the values from the vector. The first function, getNumbers, receives no arguments and returns a vector of ints. It starts off by creating a vector of type int called lotterinums. Here, we have a for loop that generates a random number, n, for 5 iterations. Notice that this rand function returns a random number between 0 and 32,767, and by getting the remainder by dividing it by 69, we will always get a random number between 0 and 68. Then, we simply add 1 more, and we get a number between 1 and 69. Continuing on the code, we have an if statement where we add n to the vector using the pushback method if that same value is not found within the code. This is done by using the find method. This find method iterates through the entire vector, starting at lotterinums.begin, which will give the reference to the first element of the vector, and ends at lotterinums.end, which will give the reference to the last element of the vector, and compares each element of the vector to the value of n to see if they match. If it does, the find method will return the reference to that element, meaning that the value is already there, and if not, it will return the reference to the end of the array, or vector, meaning it was not found and thus will be added to the vector. Here we have a function called sort to sort the elements of the array in ascending order. The second function is the setPowerball function, where a random Powerball value between 1 and 26 is generated and added to the end of the vector. It is worth noting that both setPowerball and showNumbers receive the vector parameter by reference. We are doing this because if it was passed by value, the setPowerball function will create a copy of the vector and modify it in its own stack. What is so wrong with that, you might be asking? Well, you see, because it is in its own stack, whatever modifications made to the vector will only impact the vector inside the stack, rather than the vector in the heap that is visible to the other functions. This means that if I only pass it by value, the modifications are not going to be visible when calling the Powerball function. This ampersand sign indicates what is passed is the reference to the vector. The difference between the two is that the showNumbers function adds the const clause, indicating that it cannot be modified inside the function when called, unlike the setPowerball, which can. The third method, showNumbers, displays the values from the vector in the Powerball. It consists of a for loop to print all the values of the vector aligned to the right. Then we simply print the Powerball value, first by printing PB and then the Powerball value. This is also aligned to the right. Finally, we get to the main function, where the getNumbers, setPowerball, and showNumbers functions are called. Before I continue, though, I want to talk about this gibberish right here. Before using this, I simply used a pseudo-random number generator that used the same seed every time the code was executed. Using the same seed was really efficient in testing and debugging my code. However, as the seed was the same, I was able to predict what would come in the next generation. Because of this, I figured I needed to use a random number generator that did not use the same seed every execution. This is where this srand times 0 comes in. This function generates a random seed based on the amount of hours, minutes, and seconds that have passed ever since January 1st, 1970. Obviously, this time will always change as time will always go forward, thus making this random seed generation very efficient, as I know that it will never use the same exact seed for more than a single time. the variable lotonums of type int and the variable user input of type char are assigned to 0, and you'll soon see why. We have a do-while loop that executes while the user input after the initial printing of Loto numbers is a capital or lowercase y. The reason we are using a do-while loop rather than a while loop is because a while loop only is executed while a condition is met. However, a do-while loop always executes at least one time before requiring a condition to be met for the loop to be executed more times. Inside of this loop, we print the caption prompting the user how many Loto numbers he/she wants to generate, and the scanner to read the user's input. Here we have a for loop iterating as many times as the user entered. Inside of this loop, we call the getNumbers method by initializing a vector of type int with the vector lotonums from the getNumbers method. We also call the setPowerball and the showNumbers methods. We call the setPowerball and the showNumbers functions with the reference of the vector v as a parameter. After the for loop and inside of the outer for loop, we have another do-while loop where we keep prompting the user if he or she wants to see more numbers or not while the input is invalid. Of course, what happens while the input is invalid, or letters that are not y or n? Well, this is why we have this do-while loop, where we keep prompting the user if he or she wants to see more numbers while the input is invalid. When the user enters a valid input, the do-while loop breaks, and depending on the input, the entire big do-while loop breaks or keeps executing. If the user entered y, the do-while loop continues, and if the user entered n, well, the loop breaks, and finally the code returns 0. Thank you for watching.